Okay. You might be wondering when you could ever apply this type of stuff, and I know this is going to be that easy of a problem, but it's an application. It's where you would actually use this, where businesses actually use this, for example. So, common application would be the business model for profit, revenue, and cost. We obviously profit equals the amount of money you bring in minus the amount of money you spend. So profit's going to equal revenue minus cost. Let's look at an example of that. Okay. So let's say that the marketing department of a calculator manufacturer has determined that the demand for a new model of calculator is P equals 100 minus 0.0001x. For x is between, well, obviously you want to make at least one calculator, and you can't make more than 10 million. Okay? That's the limit of your plant, or whatever. Okay, so P is the price per calculator here in dollars, and X represents the number of calculators sold. So let's say that the calculator, we're gonna make it like $100 at most expensive, but we can lower the price of the calculator for each one that we sell. So the more calculators that we sell, we can lower the price, right? All right, so then the revenue for selling X calculators is the price per calculator times the number of calculators. So this is the expression that we would use for the revenue. Okay, the total cost then is $10 per calculator plus the, let's say, developmental cost of $2.5 million to pay the employees and the engineers and the software programmers to be able to make this calculator. Okay, so $10 per calculator plus the amount of money we spent in research and development. All right. So then, what price? The real question is, what price should the company charge per calculator to obtain a profit of at least whatever we want our profit to be? All right. So let's go back and look at our revenue equation, which is this: x times 100 minus so our revenue is x times 100 minus 0.00001x. All right, our cost was $10 per calculator plus the 2.5 million. All right, so our profit equation is the amount of money we bring in minus the cost. So our profit is the x times 100 minus 0.00001x minus the cost, which is 10x plus 2,500,000. Now we want our profit to at least be 190 million. So I'm going to put 190 million here. We want to make sure that our profit is greater than or equal to that. So now we can just solve for x. We can solve for this inequality for how many calculators we must use for x to get a profit of at least 190 million. Obviously, this is going to take some algebra. All right, so now I'm going to solve this big equation, which is going to be fun, this big inequality. All right, so let me distribute. This would be 100x minus 0.00001x squared minus 10x plus 2.5 million. Okay? All right. Now let's subtract 10x, so this gives us 90x. I'm going to write this in standard form too. So let's make this negative 0.0000x squared plus 90x. Plus, and I'm going to subtract the 190 million from each side. So this is going to give us a negative 1. Let's see. $187,500,000. Okay. Now we just need to answer the question, when is this greater than or equal to 0? And that will give me the number of calculators we need to sell. Obviously, this is a parabola that opens down. So I don't know exactly where the zeros are. We obviously need to find that, but we're looking for, this range right here. When is our profit greater than or equal to 0 in this case? So that'll give me the number of calculators that we need to sell. So let's go ahead and I guess let's use the quadratic formula to find our zeros and make a sign chart. I guess we could graph it as well, but let's try to use the quadratic formula. All right, so opposite of b, plus or minus square root of b squared minus 4 times a. Supposed to be a 1 there. Times c all over 2a. Okay. All right, I'm going to go ahead and just simplify this in my calculator. Double negatives go positive, but there's one negative here. So let me go ahead and simplify this. This simplifies to 600, so it'd be negative 90 plus or minus square root of 600 over negative 0.00002. Okay, let's simplify this then. Let's just get both numbers from here. Okay, these are the zeros once you solve this. 3 million calculators about and 6 million calculators. So let's look back at the graph. And what we see then is this parabola looks like this. So we're looking for, this spot is the 3 million number, 3.2 mil. And this spot is the 5.7 million. And we need to produce calculators within this range. If we produce more than 3.2 million calculators but less than 5.7 million calculators, we'll meet our profit of 190 million. We'll meet that quota, that profit that we wanted to reach. So that's what we would say here. We would need to make calculators between 3,275,255. I'll round up because we can't make 0.1 calculators. I'll round it to 6. We're going to make more than that, but we want to make less than, more than 255 will work then, because we can't use fractional parts of calculators, so the next highest value would be 6. But less than the 5,724,744. And let's do 5 because we want to make less than that, so the next lowest one would be 4. So we need to make calculators within this range to meet our profit. Now obviously what we really want to ask is what maximizes our profit. So how many calculators should we make to maximize our profit? Which you could look at the maximum point for that parabola, which we'll do later. But this is an application of solving. This is the solution to this complex inequality. We simplified it and got this inequality. Still, it's, obviously when you're dealing with real world application, you're not going to have numbers that are nice and neat and factor and everything like that. We'll do a bunch of problems that are easier where we can factor these and easily get the zeros and make a sign chart. But this one's obviously real world, so it's going to be big numbers in this case. We're talking about millions of dollars and millions of calculators. Okay, I hope this helps.